Radio mystery in Antarctica. Scientists detect mysterious radio waves emanating from beneath Antarctica's ice. Conducting experiments in Antarctica has detected unusual radio waves originating from beneath the continent's thick ice sheet, an unexpected discovery that has puzzled scientists and raised intriguing questions about cosmic phenomena. Now let's get into the story in detail on this AI podcast.
Okay, let's dive right in. You've brought some fascinating material today about, a real scientific head-scratcher down in Antarctica.
That's right. We're talking about some unexplained radio waves. And not just anywhere, but detected coming from beneath the Antarctic ice.
Beneath the ice, okay.
Yeah.
And this is challenging some pretty fundamental ideas about physics, based on a study in Physical Review Letters, I see.
Exactly. It all centers on this experiment called ANITA, the Antarctic Impulsive Transient Antenna. It's funded by NASA.
ANITA, got it. And how does that work? What's the setup?
Well, it's pretty ingenious, actually. They use these massive helium balloons to lift sensitive radio antennas almost 40 kilometers up.
40 kilometers, wow. So way up in the stratosphere, basically looking down.
Precisely. Looking down, scanning this vast, quiet ice sheet, they're hunting for faint radio pulses.
Pulses generated by what, usually?
The idea is you have ultra-high energy cosmic particles, neutrinos, cosmic rays coming from space. They hit the ice, cause a sort of particle cascade,
And that interaction should produce a radio signal.
That's the theory, yeah. And Antarctica is perfect because it's incredibly radio quiet. Very little human-made noise to interfere.
Okay, so the expectation is signals from particles coming down from space, hitting the surface, maybe penetrating a little bit.
Right. Signals originating from above. But that's the crux of the mystery here. That's not what they found with these specific events.
Oh, so what did they see?
ANITA picked up signals that seemed to be coming up from deep within the ice, maybe even from below it entirely.
Coming up towards the balloon.
Yeah. And arriving at these incredibly steep upward angles, sometimes, as much as 30 degrees below the horizontal line from the balloon.
Wait, 30 degrees below the horizontal means it's traveling up very steeply.
Ah.
That sounds wrong. How can that be?
It should be wrong, based on what we know. One of the lead researchers, Stephanie Wissel, basically said these angles should be impossible.
Impossible because?
Because for a radio wave to reach the balloon detector from that kind of angle, it would have to have traveled up through thousands of kilometers of the Earth. Solid rock and mantle.
And radio waves just don't do that, right? They get absorbed.
Almost instantly. Standard physics says Earth is opaque to these kinds of radio waves over those distances. They shouldn't make it through.
Okay, so that's genuinely weird. Signals punching up through the planet when they shouldn't be able to. What do they think it could be initially?
Well, the obvious first suspect, given the traveling through Earth bit, was neutrinos.
Ah, right. The ghost particles. They barely interact with matter, so maybe they could make it.
That was the thinking. Billions pass through us unnoticed. They pass through the Earth. So maybe a really high-energy neutrino interacted deep down, somehow producing a radio signal that traveled the rest of the way up.
Okay, plausible maybe, but I get the feeling that didn't pan out.
It didn't. When they cross-referenced the ANITA events with data from other big neutrino detectors like IceCube, which is also at the South Pole,
Yeah.
the numbers just didn't match. The characteristics of the signals ANITA saw, the rate they saw them, it wasn't consistent with what we'd expect from known types of neutrinos interacting in the Earth like that.
So they had to rule out standard neutrinos.
Pretty much. It made the puzzle even deeper. If it's not neutrinos, what on earth is generating these signals and allowing them to reach the detector?
So where does that leave things? Are we talking like new physics?
That's certainly on the table. The source material mentions some pretty speculative ideas because, well, the standard explanations don't work.
Like what kind of ideas?
Things like maybe undiscovered exotic particles, particles predicted by some theories beyond the standard model but never actually seen.
No.
Or perhaps something connected to dark matter, the stuff that makes up most of the universe's mass, but we still barely understand it. Maybe some weird interaction there.
Wow. Okay, so potentially very fundamental stuff. Anything less exotic, more local.
Yes. They also considered if there could be some unknown effect with how radio waves travel in the ice itself, or maybe at the boundary between the ice and the air.
Like weird reflections or bending that we just don't know about?
Something like that. Could something be happening near the surface or in the fern layer, the packed snow on top that mimics a signal coming from deep below? They've done extensive analysis.
But still no clear answer.
Still no clear answer. The origin remains unknown. It really does push against our existing models.
It suggests Either some physics we haven't discovered yet, or maybe, just maybe, the first hint of something that could really change our cosmic picture.
Exactly. It points towards, well, complexities we haven't even imagined.
It's kind of mind-bending. Signals seemingly defying physics coming up from the solid Earth. It really makes you stop and think, doesn't it? If this is happening, what other truly fundamental things about how the universe works might still be completely hidden from us, maybe right under our
What
noses?
are the next steps researchers are likely to take to investigate these mysterious signals further? Don't forget to comment it. Thanks.